All right, so finishing up, this is going to be a little bit difficult at first, but we are going to work on this a little bit more in the next video as well, which will be tomorrow or whenever the next video is assigned. But basically, here is how our inverse functions are going to work. When you see something like the sine or inverse sine of -1/2, this is the same thing as saying the sine of theta equals -1/2. So in other words, if I'm only taking this portion right here, this would be like saying the inverse sine of -1/2 is equal to theta, and then when we take the inverse, and remember the inverse is just back to regular sine, we're just flipping the spots of where they go. So here, if we can figure out what theta is going to be, it's going to help us figure out what the tangent is. So what we look at here is, when is the sine of theta going to be equal to -1/2? Now, we have to assume, because we're dealing with the inverse sine, we know that we have a domain that we have to follow. So -pi/2 is less than or equal to theta, which is less than or equal to pi/2. That is always true for the inverse sine. So we know that theta has to be in between there, otherwise it doesn't work. So what we're looking at here is, if we know that it's -1/2, here's what I always do. I will draw our right triangle, because that -1/2 should be very familiar for you. We know that this right here is going to be our theta. We know that our opposite of theta is 1, and in this case -1. We know our hypotenuse is 2. So this is a special right triangle of ours. So therefore, this side has to be square root of 3. Now again, think about which quadrant that would have to be in. If we're going from -pi/2 to +pi/2, if we're looking at our quadrant, it's got to either be here or it's got to be here. Well, the only way for us to get a negative would be down in this last quadrant. So that means that if we're looking at our triangle here, there's the -1, there's our square root of 3. So now we just look at this. I know that the angle here is going to be 30 degrees, because the opposite is 1. So this has to be a 30, 60, 90 triangle. So there's our 30-degree angle. So we know that we're taking the tangent of 30 degrees, or pi/6. And it doesn't matter which one you use. Pi/6 and 30 degrees will give us the same result. Okay? But then again, what we're looking at here is, it doesn't really much matter what the pi/6 is. It doesn't matter that it's 30 degrees. In reality, we're just taking this triangle and finding the tangent of this triangle. So this is just going to simply be we have -1 over square root of 3. Well, how do I know that? Because that's opposite over adjacent. Now, the last thing we need to talk about is we have to rationalize the denominator. What does that mean? It means we have to get rid of the square roots on the bottom. So anytime you have a square root on the bottom, you just multiply by that square root over itself. Square root of 3 times square root of 3 is just 3. And then -1 times the square root of 3 would be negative square root of 3. So there's our answer. Okay, and we're going to continue going through this. A couple more problems. And like I said, we'll work on this in class a little bit more. So this next one, inverse cosine of square root of 3 over 2. Well, a couple things we can look at here. Again, we can look at our, first of all, our domain. Our domain has to be in between 0 and pi, because this is inverse cosine. Okay, so we know that that's going to be, I'll change the colors here, that's going to be either in the first quadrant or the second quadrant. So again, we look at square root of 3 over 2. We can use this exact same triangle. So square root of 3 over 2 is, that's our cosine. Well, guess what? That's going to be the exact same thing as we did before. But now look, so we have cosine of square root of 3 over 2. Let's rewrite this as cosine of theta equals square root of 3 over 2. And in reality, all that's going to do is become cosine of what? Okay, the cosine of theta equals the square root of 3 over 2. It's the same thing. Essentially, this one, these are just canceling out. The inverse and the regular will cancel out, and we'll get square root of 3 over 2. But the point is, if we continue doing this the right way, it would be cosine of pi over 6. That's what our theta would equal. Okay, so therefore we're doing cosine of pi over 6, which is exactly the same thing, which is what we just said. Square root of 3 over 2. Okay, this one is a little bit easier because they just cancel out. Okay, let's look at the tangent. We have tangent of the inverse sine of 5 over 13. So we're just looking at these different ways. These ones up here we can do by figuring out what our radians are and then doing it from there. Okay, so down here is a little bit different because we don't have our normal triangle. So let's look at this and see how this works. So we are given 5 and 13. So what's going to happen here, and this is where it's a little bit trickier, but I think in some ways this becomes a little bit easier. Again, look at this right here. This is saying the sine of theta equals 5 over 13. Again, draw your triangle. Your triangle will look like this. There's theta, there's 5, there's 13. We can actually figure out what our third side is by doing the Pythagorean theorem. 13 squared equals 5 squared plus this missing side squared. What we end up finding is that this is 12. So now, what you're looking at here is when you see what we have here, okay, this is the sine, this entire thing right here is just going to be our angle. All we're doing is looking for what this is equal to. So if what we're solving for is theta, don't even worry about what theta is. Theta is just here. This is what theta is. So in reality, we're just looking for what the tangent of theta is going to be. And the tangent of theta is going to be based on this triangle that we created. So the tangent is going to be opposite over adjacent, which is just 5 over 12. So really what you're doing is you're figuring out your triangle and then you're going from there. This is just going to be an angle right here. And the angle is, all we're doing is using this right here, the 5 over 13, to determine what the three sides are going to be, and then we're just finding what the regular tangent is from there. The inverse is only helping us figure out what that third side of that triangle is going to be. Okay? All right, so that does it for these notes. I apologize for it being this long this time. Bring questions to class again. We're going to work on this for a couple days, and we'll have some additional examples on this on tomorrow's video. So take your Edmodo quiz if that has been assigned, and I will see you guys in class.